Okay, so this is an example from the book. This is lesson 1.4, number 41, and this is just another absolute value example. Um, so here you're going to notice that you've got the absolute value on the right-hand side, which won't really change much of anything, but we do have this negative sign in front, so we need to take care of that first. So I'm going to divide both sides by -1. I could have also multiplied both sides by -1. But that's just going to leave me now with the absolute value of 2z plus 4 on the right-hand side. And now that's equal to -8z 20. So now since I've got nothing but the absolute value here on the right-hand side, I'm going to split it into the two cases. So I'm going to put my positive case over here, a equals b, and I'll put my negative case here. So the positive case is just really recopying without the absolute value sign. So -8z minus 20 equals 2z plus 4. And the negative case, I don't change the absolute value sign. So that says 2z plus 4. But I'm going to multiply the whole other side by -1. So it's -1 times the quantity -8z minus 20. Okay, so that's my negative side. So here, I guess the thing to think about is that the A is the absolute value. That's where the absolute value piece is. Okay, so I'm going to just go ahead and solve these. So first I've got a negative variable here, so I'm going to move that to the other side. Just because I would rather deal with positive signs. So -20 is equal to 10z plus 4. So subtracting the 4 out from both sides, I'm going to get -24 is equal to 10z. And so -2.4 is the z for that side. And I'm just going to write down here check because sometimes I forget to come back to it. So I want to make sure I'm not going to forget to come back to it. But I'm going to come up here and just do the algebra here first. So I distribute this -1, so that gets me back to positive 8z plus 20 is equal to 2z plus 4. This time I'm going to go this way with the z's, minus 2z on both sides, and so that leaves me with 6z's plus 20 is equal to 4. So subtracting those 20s, I'm going to end up with 6z equals -16, and dividing that out, z here will be equal to negative, I can simplify this a little bit, 8 over 3. 8/3. And I could rewrite that as 2 and 2/3, but I'm just going to leave it as the improper fraction here. So that's 8/3. Make sure that's clear. Now, I'm going to need to check, though, to make sure that both of these solutions actually work in this case. So I'm just going to get a little bit more space here. And I'm going to take it and I'm going to plug it back in the original equation right at the very top. Okay, so that's where I'm going to put it when I put in my value. So I've got 8 times -2.4 plus 20 may or may not be equal to negative absolute value of 2 times -2.4 plus 4. Okay, so I'm going to start inside the parentheses over here. So -2.4 times 2 is going to be -4.8 plus 4, still in the absolute value sign, and there's a negative outside of that. And that may or may not be equal to 8 times -2.4, which is going to be something more than 16. So 2.4 times 8 that's not right. 2.4 times 8. 19.2, that sounds right. So negative 19.2 plus 20. So now simplifying inside the absolute value signs, I've got negative 4.8 and positive 4, so it's the absolute value of negative 0.8, and that may or may not be equal to positive 0.8. It looks like 0.8. So the question here is now, is 0.8 equal to, absolute value is positive, but then there's a negative outside, so it's negative 0.8. And no, though that's not true. So this solution right here, I'm going to do it in red. This is an extraneous solution. Okay, so we just need to check the other one and see if maybe this one is a solution. So we'll check the negative 8/3 side. So we've got 8 times negative 8/3 plus 20 may or may not be equal to negative 2 times negative 8/3 plus 4. So I'm going to just turn these into fractions because I find them easier to work with. You can go a couple of different ways here, but I'm going to call that negative 64/3, just multiplying the numerators, plus if I multiply numerator and denominator by to make those thirds, that would be 60/3. So that may or may not be equal to negative the absolute value of negative 16/3 plus, if I make 4/3, I'd need to multiply it by 3, so that would be 12/3. So that is the absolute value of negative 4/3. We're going to take the negative of whatever that is. And on the other side, we've got negative 4/3. So here we end up with negative 4/3 is actually equal to positive 4/3, take the negative of it, so that's negative 4/3. So there is one solution here. This right here, negative 8/3, is a solution. Negative 2.4 is extraneous. So that's an example where one of them could be extraneous and the other one could be an actual solution. And you really don't know which is which until you go through the check. Okay, well, I hope you enjoyed and have a lovely rest of your evening. Thanks.